Now in this part of the question we're asked to work out the exact value of this area R. We've already established in an earlier part of the question that the area R is equal to this integral here. So all we need to do then is evaluate it. So we'll put over here that the area R equals, well, we've got 64 times this integral. Now to do this integral you should be able to recognize this integral straight away. The answer is it's a third sine cubed t. But let me just show you how I've arrived at that. If you were to differentiate with respect to t sine cubed t, okay, let's just put that there, sine cubed t, with respect to t, think of this as sine t all to the power 3, and then you differentiate it with the chain rule. So if that's sine t to the power 3, differentiating that becomes 3, reduce the power by 1, so it's sine squared t, and then you multiply by the differential of sine t, which is cos t. Now, 3 sine squared t cos t is not what we've got to integrate. There is no 3 in the answer up here. But if I had to differentiate 1/3, a constant times sine cubed t, then what I would have is 1/3 of the 3 sine squared t cos t as an answer. And what is 1/3 of 3 sine squared t cos t? Well, those thirds, that 3 I should say, cancels out and gives sine squared t cos t. So hopefully you can see that this integral is 1/3 sine cubed t. So I'm going to put the 3 from the third underneath the 64, okay, and then because we have limits in this, we just use some square brackets, and we have sine cubed t going from the lower limit pi upon 3 to the upper limit pi upon 2. Now if you couldn't see this as a way of integrating sine squared t cos t, then you could do this by substitution. The substitution that you could make is u equals sine t. So you could try that, and you should find that you will get the answer that I'm going to come to regardless. Okay, so carrying on now, all I need to do is substitute pi upon 2 and pi upon 3 in for the limits. So we have 64/3, and then we have sine cubed t, which is now pi upon 2, whoops, okay, minus sine cubed pi upon 3. Well, the sine of pi upon 2 radians is 1, so we have 1 cubed, which is just simply 1, so that's 64 over 3 multiplied by 1. Then minus, now the sine of pi upon 3 radians is root 3 upon 2, so we have root 3 upon 2 to be all cubed. So working this out, we have 64/3 multiplied with the 1 is 64/3. Now root 3 upon 2 all cubed is going to be 3 root 3 upon 8, and if you multiply it with 64/3, what you should find you get is minus 8 root 3. So we have that the area, let's just put it down, area R then equals 64/3 minus 8 root 3. And we're told to write this in the form a plus b root 3, stating our values of a and b. So you can see that this is identical to a plus b root 3, where clearly a is 64/3 and b is minus 8. And that brings us now to the end of this question.